NASA's Artemis II mission, a crewed test flight around the Moon, is currently targeting a launch no earlier than September 2025 from Kennedy Space Center, Florida. This mission will carry 4 astronauts: Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen, aboard the Orion spacecraft, launched by the Space Launch System (SLS) rocket. Unlike the Apollo missions, Artemis II will not land on the lunar surface. Its primary objective is to validate the Orion capsule's life support systems and heat shield performance during a high-speed re-entry, preparing for future lunar landings. The mission is a critical step in NASA's broader Artemis program, which aims to establish a long-term human presence on and around the Moon, ultimately paving the way for human exploration of Mars. The crew will spend approximately 10 days in space, traveling around the Moon and returning to Earth, marking the first time humans have ventured beyond low Earth orbit since Apollo 17 in 1972. This uncrewed test flight, Artemis I, successfully completed its mission in late 2022, demonstrating the SLS rocket and Orion spacecraft's capabilities. The Artemis II mission is a direct precursor to Artemis III, which is planned to land astronauts on the lunar South Pole. The total cost of the Artemis program is estimated to be in the tens of billions of dollars, with the SLS rocket alone costing billions per launch. This mission represents a significant investment in human spaceflight, aiming to push the boundaries of exploration further than ever before. The launch window and exact date are subject to change based on ongoing testing and readiness reviews of both the spacecraft and ground systems. Artemis I's mission profile involves a complex trajectory designed to test Orion's systems under conditions similar to a lunar return. The spacecraft will travel approximately 230,000 miles, 370,000 kilometers, to the Moon, performing a lunar flyby that will take it around the far side, reaching a maximum distance of about 4,600 miles, 7,400 kilometers, beyond the Moon. This free return trajectory uses the Moon's gravity to slingshot Orion back towards Earth, minimizing the need for propulsion. The mission duration is planned for about 10 days, during which the 4-person crew will conduct various tests, including manual flight maneuvers, life support system checks, and communications system evaluations. The Orion capsule, designed to accommodate 4 astronauts, has a mass of approximately 23,000 pounds, 10,400 kilograms, for the crew module, and stands about 10.8 feet, 3.3 meters, tall. The entire SLS Block 1 rocket, including Orion, stands 322 feet, 98 meters, tall, generating 8.8 million pounds, 39.1 meganewtons, of thrust at liftoff, making it the most powerful rocket currently in operation. The crew will experience speeds of up to 24,500 miles per hour, 39,400 kilometers per hour, during re-entry into Earth's atmosphere, generating temperatures of nearly 5,000 degrees Fahrenheit, 2,760 degrees Celsius, on the heat shield, a critical test for future deep space missions. This velocity is significantly higher than that experienced by spacecraft returning from low Earth orbit, demanding robust thermal protection. The Artemis II mission draws direct parallels to Apollo 8, the first crewed mission to orbit the Moon in 1968, but with significantly upgraded technology and a different strategic objective. While Apollo 8 proved human capability to reach lunar orbit, Artemis II aims to validate the Orion spacecraft for sustained deep space human presence. The Space Launch System (SLS) rocket, while visually reminiscent of the Saturn V, incorporates modern propulsion and avionics, including upgraded RS-25 engines derived from the Space Shuttle program and solid rocket boosters. Artemis I, the uncrewed test flight in 2022, successfully demonstrated the SLS and Orion's ability to reach lunar orbit and return, traveling 1.4 million miles over 25 days, exceeding its planned duration and proving the heat shield's integrity. This success provides critical data for Artemis II. Unlike Apollo, which used a lunar module for landing, Artemis I's Orion capsule is designed for crew transport and re-entry, with the Human Landing System (HLS) currently being developed by SpaceX's Starship, intended for the actual lunar surface descent on Artemis III. The Artemis program also distinguishes itself by aiming for a sustainable lunar presence, including the Gateway Lunar Orbital Outpost, rather than the flags and footprints approach of Apollo. The crew of Artemis II includes the first woman and first person of color to travel to the Moon, a stark contrast to the all-male, all-white crews of the Apollo era, reflecting a broader shift in NASA's approach to diversity and inclusion in space exploration. Artemis II is more than just a test flight, it represents a significant geopolitical and scientific statement. By returning humans to lunar proximity, NASA aims to reassert American leadership in deep space exploration, a domain increasingly contested by other nations like China, which has its own ambitious lunar program. The mission also serves as a proving ground for international collaboration, with the Canadian Space Agency's participation underscoring a growing global partnership in space. Scientifically, the mission will gather valuable data on the physiological and psychological effects of deep space radiation on a human crew, information critical for future long-duration missions to Mars. The experience gained from operating Orion with a crew will inform the design and procedures for the Gateway Lunar Outpost and the Human Landing System, both integral to establishing a sustainable lunar presence. Economically, the Artemis program stimulates the aerospace industry, fostering innovation and job creation across numerous contractors and suppliers. However, the program's high cost and reliance on a single, government-developed heavy-lift rocket, SLS, have drawn criticism, with some advocating for greater reliance on commercial partners and more cost-effective launch solutions. The success of Artemis II is crucial for maintaining public and political support for the ambitious, multi-decade endeavor of returning humanity to the Moon and eventually Mars. Following the successful completion of Artemis II, the next major milestone is the Artemis III mission, currently projected for no earlier than 2026. Artemis III aims to land the first woman and first person of color on the lunar South Pole, a region believed to contain water ice in permanently shadowed craters, which could be vital for future lunar bases. However, the Artemis program faces several significant challenges. The development of the Human Landing System, HLS, by SpaceX, specifically the Starship vehicle, has encountered delays and technical hurdles, pushing back the Artemis III timeline. Similarly, the Gateway Lunar Outpost, intended to serve as a staging point for lunar surface missions, is still under development. The high cost of the SLS rocket and Orion capsule continues to be a point of contention, with each SLS launch estimated to cost over $2 billion. Maintaining consistent funding and political will across multiple administrations is also a perennial challenge for long-term space programs. Furthermore, the harsh radiation environment of deep space and the Moon's surface poses ongoing health risks to astronauts, requiring advanced shielding and mitigation strategies. The success of Artemis II is paramount to building confidence in the entire program and demonstrating that NASA can deliver on its ambitious goals, paving the way for a sustained human presence beyond Earth.